This is a video from section 6.2. The directions say to find the volume of the solid obtained by rotating the region bounded by the given curves about the specified line. So we're going to start with number 11 in the Stewart Calculus Textbook, 9th edition. Suppose we're given the lines y equals x plus 1, y equals 0, x equals 0, and x equal 2. So we're going to rotate the region bounded by those lines about the x-axis. Now, when we slice through the point x, we get a disk with radius x plus 1. Now, the cross-sectional area of that disk is a of x is equal to pi times the radius squared, where the radius is x plus 1. And one quick comment here that you may notice, if we slice perpendicular to the x-axis, we're going to integrate with respect to x. And if we slice perpendicular to the y-axis, we're going to integrate with respect to y. And so the volume is the integral from 0 to 2 of a of x dx, where a of x is pi times x plus 1 to the second. So then we're going to get the integral from 0 to 2 of pi times x plus 1 to the second dx, but that's pi over 3 times x plus 1 to the third, evaluated from 0 to 2. So I'm going to pull the pi over 3 out in front. If I plug 2 in for x, I get 3 to the third. If I plug 0 in for x, I get 1 to the third. So I get pi over 3 times 3 to the third minus 1 to the third. 3 to the third is 27. 1 to the third is 1. 27 minus 1 is 26. So the answer for problem 11 is 26 pi over 3. If we take a look at 13, suppose we're given the curve y equals square root of x minus 1, the line y equals 0, and the line x equal 5. And we're going to rotate that region about the x-axis. Now, when we slice through the point x, we get a disk with radius square root of x minus 1. And the cross-sectional area is a of x is pi times square root of x minus 1 to the second. So the volume is the integral from 1 to 5. And, you may notice we're starting at 1, right? X equal 1. And we're ending at 5. Okay? So those are my limits of integration. So we're taking the integral from 1 to 5 of a of x dx, which is the integral from 1 to 5 of pi times the square root of x minus 1 to the second dx. But square root of x minus 1 to the second is x minus 1. So we have the integral from 1 to 5 of pi times x minus 1 dx. If I pull the pi out in front, I get pi times the quantity 1/2 x squared minus x, evaluated from 1 to 5. So I get pi times the quantity. Now I'm going to plug 5 in for x. I get 25 over 2 minus 5. If I plug 1 in for x, I get 1/2 minus 1. And I'm going to subtract those results. And when I simplify, you will come up with 8 pi. And that's the answer to problem 13. If we take a look at 15, suppose we're given the curve x equal 2 square root of y, x equals 0, y equal 9, and we're going to rotate about the y-axis. So if we slice at height y, the cross-section is a disk with radius 2 square root of y. So you notice we're slicing perpendicular to the y-axis. We're going to integrate with respect to y. Now, the cross-sectional area is a of y is pi times 2 square root of y to the second, which is equal to 4 pi y right here. Now, the volume is the integral from 0 to 9 of a of y dy, but a of y is 4 pi y, so we're integrating from 0 to 9 of 4 pi y dy, which is 4 pi y squared over 2 evaluated from 0 to 9. And so the correct answer here is 162 pi. And that's problem 15. If we take a look at 17, suppose we're given the curve y equals x squared. Of course, that's a parabola. And the line y equals 2x, and we're going to rotate that region about the y-axis. If we slice at height y, the cross-section is a washer. And so think of, you have an outer circle, you have an inner circle, and you're looking for this area in between right here that I have in red. Okay? Now, if y equals x squared, notice that x equals square root of y, and if y equals 2x, x equals 1/2 y. Now, the outer radius, okay, let's take a look at the picture here. The outer radius is the distance from here to the y-axis. The inner radius is the distance from here to the y-axis. So if we notice, the outer radius is square root of y, the inner radius is 1/2 y. So the cross-sectional area is pi times the outer radius squared, which is square root of y squared, minus the inner radius squared, which is 1/2 quantity squared. But square root of y squared is y, 1/2 y squared is 1/4 y squared. So we get pi times the quantity y minus 1/4 y squared. So we're going to take the volume as the integral from 0 to 4, right, of a of y dy. But that's pi times the integral from 0 to 4 of y minus 1/4 y squared, right here. So that's pi times the quantity 1/2 y squared minus 1/12 y cubed, evaluated from 0 to 4. If I plug 4 in for y, I get pi times the quantity 16 over 2 minus 64 over 12. So the answer here will be 8 pi over 3. And that's number 17. If we take a look at 21, suppose we're given y equals x squared, x equals y squared, so these are two parabolas, and we want to rotate about the line y equals 1. And notice y equals 1 is a line parallel to the x-axis. And so if we slice through x, we get a washer. Okay? Now, we need an outer radius and we need an inner radius. And I would think about it this way. I'm going to go back to the picture and we're going to explain. The outer radius is 1 minus x squared. So think of the bigger radius. The inner radius is 1 minus the square root of x. So if we go back, so remember I'm rotating about y equals 1. So if I take the distance from y equals 1 to the x-axis, this is a distance of 1, right? And I want the outer radius. So think of, again, the bigger radius. So I'm going to take the distance from y equals 1 to the x-axis, and I'm going to subtract the distance from this curve, which is y equals x squared, to the x-axis. So the outer radius will be this distance minus this distance. So 1 minus x squared. Okay? And remember, if x equals y squared, so let's write that over here. If x equals y squared, then y equals the square root of x. And so to get the inner radius, I'm going to take the distance from y equal 1 to the x-axis, and I'm going to subtract the distance from y equals 1 to this curve here in red, which is x equals y squared. But remember, if I solve for y equals the square root of x. So that's the inner radius. So the outer radius is 1 minus x squared. The inner radius is 1 minus the square root of x. The area of the cross-section is pi times the quantity 1 minus x squared to the second minus 1 minus square root of x to the second. And if I simplify, I get pi times the quantity x to the fourth minus 2x squared minus x plus 2 root x. So just did a little algebra and simplified. Notice the ones cancel, and we simplified that. So the volume is the integral from 0 to 1. And just kind of by the way there, notice how the graphs meet at 0, 0, and 1, 1. So x is going from 0 to 1. So we're going to take the integral from 0 to 1 of a of x dx, which is pi times the integral from 0 to 1 of x to the fourth minus 2x squared minus x plus 2 root x, which is pi times the quantity 1/5 x to the fifth minus 2/3 x to the third minus 1/2 x squared plus 2 times 2/3 x to the 3/2, evaluated from 0 to 1. If I plug 1 in for x, I get pi times the quantity 1/5 minus 2/3 minus 1/2 plus 4/3. And I just simplify that, right? And I end up with 11 pi over 30. I got a common denominator up above. That was 30, and rewrote each of the terms, each of the numbers, with a 30 in the bottom. And then lastly for this video, I wanted to take a look at number 25. If y equals x cubed and y equals 0 and x equals 1, so we're going to rotate the region bounded by that curve and these two lines about x equal 2. So if we slice at height y, the cross-section is a washer. And I'm going to do the same idea, right? Notice that the distance from here, from the y-axis to x equal 2 is 2. And remember, I'm trying to get the outer radius. So I'm going to subtract off the distance from the y-axis to the curve y equals x cubed to get the outer radius. So I hope that makes sense. So the outer radius will go, I'll write that in blue here. I'll draw it in blue. This is the outer radius in blue. So I take the distance from x equal 2 to the y-axis, and I subtract the distance from the y-axis to the curve y equals x cubed to get the outer radius. So that'll be 2 minus cube root of y. And The inner radius will be the distance from x equals 2 to the line x equals 1. So it's 2 minus 1. And so the cross-sectional area is a of y is pi times the quantity, 2 minus cube root of y to the second minus 1 squared. And when I simplify, I get pi times the quantity, 3 minus 4 cube root of y plus y to the 2/3. And then I'm in business. The volume is the integral from 0 to 1 of a of y dy, which is pi times the integral from 0 to 1 of 3 minus 4 cube root of y plus y to the 2/3, which is pi times the quantity 3y minus 4 times 3/4 y to the 4/3 plus 3/5 y to the 5/3, evaluated from 0 to 1. And when I'm all done, I get 3/5 pi. Okay, and that'll do it for this video for section 6.2. And we worked problems 11, 13, 15, 17, 21, and 25 from the Stewart Calculus Textbook, 9th edition. Thank you.